Hi, my name is Amy, and the structural failure I'm going to cover is the I-35 West Bridge collapse over the Mississippi River. And so this bridge was constructed in Minneapolis and was supported on four piers. And what contributed to the failure of this bridge that we'll get into a little bit later is that its design was non-redundant, and this meant that it was fracture critical. Basically, there were no alternative load paths if the single load path that existed failed. And so, what mainly supported this bridge was two main trusses, and the members of the trusses were joined together at nodes with gusset plates, which you can see to the right here. And this was actually the problematic gusset plate that ultimately led to the bridge's failure. You can see the dimensions here that it was half an inch thick, 9 feet long, and 6 feet high. And the deck of this bridge was originally designed to be 6.5 inches thick, but modifications were made to make the deck thicker. And so again, the U10 gusset plate, U10 means that it was joining the top of the truss and it was the 10th node from the south end. But anyway, this gusset plate failed because it was about half as thick as it needed to be. Like I mentioned, increases in the bridge's weight from heavier barriers and a thicker deck, as well as added loads from construction materials and backed up cars from traffic, were kind of the straw that broke the camel's back that day. And at the time, designers thought that connections were a lot stronger than the members that they joined together, and so they really weren't concerned about performing extra calculations for them. And the popular load rating software programs at the time, like BARS and Vertus, left out the strength of connections in their analyses altogether. And actually, neither the Minnesota DOT nor Jacobs, which was the company that acquired the original company that designed this bridge, could find the calculations for the gusset plates on the main truss. And so the Federal Highway Administration ended up recreating these calculations using the same process the engineers at the time would have done them. They found that the demand to capacity ratio for the U4, the U10, and the L11 nodes for shear stress were bigger than 2. And this means that the demand that was placed on those half an inch thick plates was more than double what they were designed to handle. Okay, so lessons learned. The load rating software that the designers used were misleading and that they didn't consider the gusset plates, and now we're aware that connections are important and need to be taken seriously in design. Also, after the collapse, Minnesota DOT started requiring independent third-party reviews for all major bridges, and bridges are now more often built with alternative load paths and static indeterminacy. And we've now incorporated gusset plates into inspections as per the National Transportation Safety Board's recommendations, when we really didn't have too much guidance on how to inspect them before, and now we know that we need to more strictly regulate construction loads. That's all I have for today. Thank you for watching.